In this video, I wanted to talk about problem number 42 from the second lesson of our Calc 1, Unit 5, Part 1. So we're talking about Unit 5, Part 1, Lesson 2, the series of integrals that I asked you to complete on paper. This was number 42. When I assigned these, I didn't expect us to use too many of the real complicated examples of integrals. But this one is, I wouldn't say very complicated, but it is necessary for us to reference a few of our integral rules. Now, next week, during part 2 of the unit, I'm going to have the integral rules available to you. But I think what I'll do is I'll make a copy of this available to you early on the page, and it'll be attached to the page where this video is displayed. But essentially what we're doing is we're finding the antiderivative of this fraction, sine theta minus 1 over cosine squared theta. And one of the first tricks that I would apply if I can't find this rule in the antiderivative list is I would split this fraction into two fractions. And we can do that because we have a single denominator and we have two parts to our numerator. So what this allows me to do is to create two fractions. One fraction is going to contain a numerator of this value, and the other fraction is going to contain a numerator of this value, and both fractions have to have the same denominator. And so that's what we see here. We're going to expand this integral into two integrals, both relative to theta. Then, with some of our trigonometric knowledge, we can rewrite these expressions into a single form or a single version of the trig rules. So this sine theta, cosine theta, this guy right here, I'm again going to split into two fractions. This time I'm going to treat this like sine theta over cosine times 1 over cosine. The product of these two fractions, of course, is sine over cosine squared. And this one on the right-hand side, I'm going to recognize that, well, this is just the inverse of cosine squared. And so not the inverse, but the reciprocal. This is the fraction flipped over. And the reciprocal of cosine is also known as secant. So the reciprocal of cosine squared is going to be secant squared. Back to the antiderivative on the left, sine over cosine is going to be rewritten as tangent. Now we've got a single trigonometric function instead of a fraction. And again, the reciprocal of cosine is secant. So this phrase really is tangent of theta times secant of theta. Now this is particularly helpful for us because when I do look at my antiderivative list, now I'm going to see something. This pattern is pretty common. I didn't know exactly what it was off the top of my head, but I did recognize it, as is this pattern. Now this one I did have memorized. The antiderivative of tangent times secant comes to us from rule number 42. It's written in an opposite direction, but it is essentially the same thing, where secant, they're using a and x for their angle measure, but secant of a constant times x raised to some power times tangent of a times x is equal to this format here. Now, as it turns out, tangent secant, well, that's like secant being raised to the first power with an a value of 1. So essentially we don't need to see those. We've got secant of x times tangent of x. The a values are 1. So I'm going to treat this result. A value is 1, the n value is 1, and the a value is 1. And so the antiderivative of secant times tangent is simply just secant plus c, as long as n is not equal to 0. Now, I should have known better because that is a derivative rule that I asked you to memorize, and I myself forgot it, but that's okay. We were able to find the antiderivative using the antiderivative rules. If you were well versed and you remembered all of the derivative rules that you memorized at the start of the semester, then this one should have been familiar to you. Now, as I said a moment ago, this one I did recognize, this secant squared. I knew that one immediately as tangent. And if you forgot that, well, we do have another antiderivative rule here. This one happened to be 32. Secant squared of some constant times x. Well, the variable was multiplied by a constant. It just happened to be the number 1. We can treat this as 1 times theta. So secant squared of 1 times x, or 1 times theta, is 1 over 1 times tangent of 1 times x. Or in other words, the antiderivative of secant squared is indeed tangent. So that's nice to see that the antiderivative of tangent times secant is just secant. And we're going to put our plus c here because that is the antiderivative of this expression. We're going to subtract the tangent theta because tangent theta is the antiderivative of secant squared. And that contained a plus c as well. Now we do have to be a bit careful and a bit more deliberate with our c values. This c value on the left is not necessarily the same as this c value on the right. So unlike the fundamental theorem of calculus, when we subtract two integrals, the c values would cancel. That's not necessarily going to happen here. We would essentially need an initial value for both this function and this function to verify our c values. We don't have that. So we can't trust that this c value will cancel with this c value, but we can say that they will combine to make another constant. Some constant plus or minus another constant will be a separate constant altogether. And so we're going to note that the final derivative here, antiderivative, is secant theta minus tangent theta plus a single c. There are some schools of thought that will say not to worry about computing or identifying c values at all along the way. And they will say that the antiderivative of this expression is secant, the antiderivative of this expression is tangent, and when all is said and done and all work has been completed, then we'll come by and add the c value at the end, which is fine. That's not the way I was taught, and that's not the way I'm going to lead this class. But if you're watching other videos or if you talk to anybody else that's taking this course, it would be fine if you follow their recommendation. So I hope that explanation helps. Let me know if you have other questions.